So I don't know. I always like when I'm learning something to kind of be able to put it in context. And I keep doing that to you. And that's what this lecture is all about. Again, maybe this is because I taught the history of psych and suddenly everything's history of psych to me. I don't know. But I think it's kind of cool. And because this one has such a good University of Toronto connection, then I wanted to kind of emphasize this too. You might be walking around campus or see things inviting you to the Ebbinghaus Empire. And if you do, you will be learning from a bunch of people who were very inspired by this guy named Hermann von Ebbinghaus. So why is he so inspirational? Well, the story really has to go back to Pythagoras and then Newton. So all of you guys who hate math and just want to be scientists, but why is there all this math? Why do I have to do a stats course? Yada, yada. These are the guys. It's these guys' fault. Pythagoras especially, very early on, he fell in love with math. And Pythagoras, by the way, is a fascinating character. He had a cult of people following him. They were all vegetarian. He was a vegetarian, so I was kind of thought that was kind of cool. But they really saw mathematics as beautiful. And he was one of the first to describe the mathematics underlying geometry. So things like the famous Pythagoras theorem with right-angled triangles and how the square of the hypotenuse equals the square of the sides summed together, etc. He would see math in things and things like music as well, right? The notes that sounded good, and in order to get the same note at a different octave, you have the length of some string that you pluck, and if you exactly half it, you get that exact same note in a different octave. And so he saw math underlying everything, and in fact, was just fascinated and felt that when you could describe something mathematically, then you were onto the truth. And so there became this linking between mathematics and sort of some underlying truth of nature. And if you could capture something mathematically, that was the truth. And in fact, Newton, of course, in his day, which, by the way, just to give you context, late 1600s, he really, with his laws, the laws of physics that Newton kind of described, everything was mathematical, right? He could describe, motion and all these things using mathematical equations. And that again really felt like when you can do that, then you're getting at laws of nature, you're getting at the accurate truth. And so many scientists were influenced by these two and by that basic notion that you're really doing science when whatever it is you're studying you can capture using mathematics. We already told you that in the early days of psychology this was important. When psychology was trying to say that you could study the mind scientifically, one of the things they used to make that argument was mathematics. If you remember Ernst Weber and things like Weber's law or Fechner's law, again, Weber and Fechner pretty much doing similar things, but the fact that, remember that just noticeable difference, and they said, well, how much of a difference do you need to detect, that say this one is heavier than this one? Well, that depends on the weight of the standard. So the heavier the original thing is, the more of a difference you're going to need before you feel it. And in fact, it's a constant ratio. So that was Weber's law, the fact that amount of difference you need is a ratio of the original one, and that ratio remains constant. The fact that he could show that mathematically about perception and how we perceive the world really made people think, and this was actually before psychology. He called himself a psychophysicist. Nobody was a psychologist at that point, but that paved the way to psychology being born. Okay, so this is where Hermann von Ebbinghaus now fits in, and I've probably told you a little bit about him before. I'm realizing now that I'm forgetting a little bit of what I might have told you because I tell these stories so much. But even if I have, now you're going to get it in context, and I think it'll make a lot more sense. So Hermann von Ebbinghaus, here he is. And again, let's look at the time period he's in, 1850 to 1909. What Hermann von Ebbinghaus was trying to do was to show that not only things like how we perceive the world, but even our memory of things, if you study them well, you can capture memory mathematically. And this would have been this was a really big deal because memory was just this vague concept, right? Nobody ever saw memory. And you know, it's just this internal ability we have to recapture the past. And he thought he could study this scientifically. And so he was kind of following on from the Webers and Fechners of the world. And he was known for his scientific rigor. So, you know, he did things like the following. He created these CVCs, and I think I have told you about this, so I'll go a little quick, but just to remind you, he created these CVCs, constant vowel consonant strings like these. You see 8 of them there. And he would do these studies on himself, where he would give himself a list of these, let's say 20, and he would try to remember them all. So he would go through the list and he'd flip it over and write it all down and see if he could get all 20. And of course he couldn't for a while, so then he'd flip it back over, study it harder, and then try to write them all down. And eventually, after he studied them enough times, he could write them all down. And in fact, in his Ebbinghaus way, writing it down once wasn't enough. If he felt he wrote them all down right, he would flip that sheet over and do it again. And if he could recall it accurately twice in a row, then he said, okay, I learned it. Okay? Then he let time pass. He didn't look at anything. And he would come back to these things, and he would see where he was. And as time passed, he would lose a lot of the memory. So, you know, if he just let an hour pass and tried to write all 20, he couldn't do it anymore. He might be down to, well, here's a day passed, down to 80% that he could remember. But what he found is that if he then tried to review it again, he could learn it back really quick. So it took him a long time originally to learn it, but to relearn it was relatively quick. And in fact, as he did this over and over again, you always forget, and it seems like you forget, but it seems like if you go back and relearn it, you can get it back really quickly. Now, the really kind of interesting thing is, again, he's using math. He's showing things in this sort of way. In fact, he was able to create what he called a forgetting curve, which was just, you know, I've got those 20 things in memory. Now I'm going to flip them over, and I'm going to test my memory every now and then. And as time goes by, here in hours, you're seeing him, you know, lose that information. Now, this is when he tried to remember this is the difference here is this was a small list. And so he was, you know, he could remember 80% of it after a day. If it's just a 5 or 6 item list, this was a longer list. And so when he tried to remember, say, 16 or 20 items, then just after a short period of time, he was starting to lose those items. But he could show mathematically how things seemed to be forgotten, and also show that they weren't actually forgotten. And so he did a bunch of geeky kind of stuff, including the association. So if you remember an item, then what about the next item? Are you more likely to remember it if you remembered the previous? And so he was looking at how memory kind of connected with one another and doing all this fancy stuff. So all this to say, he was doing really kind of complex, precise science of memory. And then he got kind of forgotten. Why? Look at the date, 1909. This was right around the time when behaviorism was beginning to rise over those next 10 and 20 years. And so people started turning away from the old ways of doing science and going towards this stimulus response kind of stuff, which Ebbinghaus's work didn't really fit within. And so he largely did not get the attention he deserved until cognitive psychology emerged on the other side of behaviorism, and then started studying memory, you know, very, very seriously. And that was the University of Toronto days, by the way. In the sort of 1950s, 1960s, there was a resurgence in interest in memory. And that's why University of Toronto calls themselves the Ebbinghaus Empire. They're going to follow on the footsteps of Ebbinghaus. But there was a gap of a good 50 years before that kicked in. That led to cognitive psychology. That was the kind of psychology I studied and the memory that I've done. And a lot of the things you're going to learn in this chapter are from that period of the sort of 1960s to 1990s and a little beyond. But that was the real heyday of memory research, and University of Toronto was right in the middle of it. Cool. Excellent. Onward to your chapter. Bye-bye.